Okay, this video we're looking at relative masses. So when we say relative masses, it's because we compare them to one particular thing, and that's carbon-12. Because one thing we know is that 1 mole of carbon-12 weighs 12 grams. So when we're talking about 1/12 of a weight of a carbon-12 atom, we're talking about one atomic mass unit, really. Okay, so we compare everything to carbon-12. It gives us a standard, because otherwise the numbers that we use would be so small it'd be hard to make sense of what we're looking at. So that becomes part of our definitions. If we look at a particular type of atom of an element, an isotope, the relative isotopic mass is the mass of an atom of an isotope compared with 1/12 of the mass of an atom of carbon-12. But all atoms of an isotope, a particular isotope, all weigh exactly the same. So there's no need for the word average or anything like that or mean here, because all atoms of one particular isotope will weigh the same amount. When we talk about relative atomic mass, which sometimes you see written like this, a capital A, a sort of a subscript R, it's the weighted mean mass of an atom of an element compared with 1/12 the mass of an atom of carbon-12. So weighted mean mass because we're taking the average of all the different isotopes of that element. And both definitions, it's very important you have this 1/12 of a carbon-12. The different isotopes of carbon itself is carbon-13 as well, so you must specify it's carbon-12. So if you wanted to find that mean, that weighted mean mass, how do we do it? Well, here are two isotopes of chlorine, chlorine-35 and chlorine-37. So there's a difference in the mass number there, the isotope mass number. Okay, so here we've got the abundances. So that's how much of it is around in the universe, yeah, or on Earth. So chlorine atoms of 35, we've got 75% of them, of those of chlorines weigh 35, while 25% have a mass of 37. Okay, they're the abundances. So when we want to find the average of relative atomic mass, we do the mass, take one of the masses and times it by its abundance, and then we take the mass of plus on the mass of the other one times by its abundance, divided by the total abundance. So in this example, we take the 35 times 75, we plus on 37 times 25, and the total abundance, normally if it's a percentage it would be 100, but do check with the information I give you, that plus that is 100, and that gives us 35.5. Okay, so that's a relative atomic mass. No particular chlorine atom has a mass number of 35.5. You can't get a half number, but the average of all chlorine atoms would be 35.5.